This is my third video lesson for Unit 6A. In this lesson, we will predict if a double replacement reaction will occur spontaneously or not. So go to page 13 in the class packet. Motivation. Here we have an analogy of a double replacement reaction. Predict which is more likely to happen, choice A or choice B. In a double replacement reaction, there's two ways that things can switch, choice A and choice B. In choice A, an accessory and an animal switch places. In choice B, only the accessories switch places. One of them is correct in a double replacement reaction. Which is it, choice A or choice B? As you must guess, choice B is the better answer. So keep this analogy in mind as we talk about the double replacement reaction in this lesson. Learning target. At the end of the lesson, I'll be able to identify if a double replacement reaction is spontaneous using table F. Write the net ionic equation. So there's two parts to this lesson. Homework will be number 3, which is a Junipod based off this lesson. The next exam will be on Unit 5C and Unit 6A. Here's a double replacement reaction. Similar to the motivation, there are two possibilities based on how the ions will switch. One of them is correct. I color-coded the metals and the non-metals. Metals are red, non-metals are blue. Which is correct and why? Choice A is the correct one. Why is that? Because in a double replacement reaction, you're basically switching the ions around. So these are still ionic compounds, so it must be between a metal and a non-metal, because metals are positive, non-metals are negative. In choice B, you have a positive with a positive ion. They're going to repel each other. You have a negative with a negative ion. They're also going to repel each other. So in the double replacement reaction, when an ion switch, you're still forming an ionic compound, so it must be between a metal and a non-metal or positive ion with a negative ion. Check of understanding number 1. Predict the products of the following reactions. So I'm going to do question 1 as an example. Here we have two ionic compounds, sodium bromide and silver nitrate. Since they're both compounds, they're going to do a double replacement reaction. We first got to figure out the charge of each ion. Sodium is a positive ion because it's a metal. Bromine is a negative ion because it's a nonmetal. Silver is a positive ion because it's a metal. Nitrate, which on table E, is a negative ion. So when a double replacement reaction happens, the sodium is going to switch places with the silver. When it does that, the sodium is going to bond with the nitrate because opposites attract, and the silver is going to bond with bromine. If you do that, you get sodium nitrate plus silver bromide. In number 2, we have another double replacement reaction between two compounds, potassium carbonate and calcium nitrate. The first step is to figure out the charge of each ion. Potassium is a metal, and it has a charge of positive 1. Carbonate, if you look on table E, has a charge of minus 2. Calcium has a charge of positive 2, and nitrate has a charge of negative 1 if you look on table E. So since potassium and calcium are both positive, they're going to switch places during the double placement reaction. So potassium is going to bond with nitrate, and calcium is going to bond with carbonate because opposites attract, and you form potassium nitrate and calcium carbonate. To get the formula, you have to crisscross the charges of the ions, and then you have to balance the chemical equation afterwards. That's why I put a 2 in front of the potassium nitrate. Now I want you to try 3 and 4 on your own. Pause the video and resume once completed. Okay, so here's the answers. So the question is, will any of these reactions actually occur in real life? These chemical reactions may react in theory, but if you were to mix these two substances in a lab, would they actually react? We will discuss this in this lesson. We are first going to define the term spontaneous. When something is spontaneous, it means it occurs without effort or assistance from external help. It happens automatically. So here's an example. Let's say we have a ball. It's going to roll down the hill on its own. It's going to happen automatically without anybody helping it. Let's do a few more examples. Let's say someone farted in the room. The smell of the fart spreads across the room. Is that spontaneous or not spontaneous? It is spontaneous because eventually everybody will smell it. How about pushing a car across the road? Is that spontaneous or non-spontaneous? That is not spontaneous because there's an external force pushing the car. What about dissolving food coloring in water? Is that spontaneous or not spontaneous? That is spontaneous. If you drop food coloring in water, it'll automatically spread out in solution and mix with the solvent, as you can see from this GIF. So a double replacement reactions are spontaneous if one of the products is water or gas or precipitate. We will discuss what a precipitate is. A precipitate is an insoluble solid. Insoluble means it does not dissolve. In the case with double replacement reactions, it means that the substance does not dissolve in water at STP. So usually a precipitate will have a symbol S next to the substance. This reaction is showing lead nitrate reacting with potassium iodide to form lead iodide and potassium nitrate. You can tell from this chemical equation that lead iodide is a solid. That's the yellow stuff in this GIF here. So because it's forming a solid substance or a precipitate, this chemical reaction is spontaneous. If you look at the reactants, each reactant is dissolved in water. That means that there's water around in this reaction. So lead iodide is a precipitate because it's not dissolving in that water. So whenever a double replacement reaction forms a precipitate or water or gas, it is spontaneous. If it does not, then it's not spontaneous and you're just doing a physical change, which is just mixing two things. Check of understanding number 2. Explain why each of the following chemical reaction occurs spontaneously. In each double replacement reaction, we must check the products, whether there's a gas, water, or precipitate in order for the double replacement reaction to be spontaneous. In the first one, we see we're forming CO2 gas, therefore it is spontaneous. In the second one, we're forming water, therefore it is spontaneous. If you look at the third equation, we're forming an insoluble solid in the presence of water, therefore it is spontaneous. PbI2 is a precipitate. In the fourth reaction, H2CO3 can further react and decompose to CO2 and water. Since it's forming CO2 and water, this chemical reaction is spontaneous. At this point, you should be able to predict the products of a double replacement reaction and tell if it's spontaneous or not based off its products. The next part of the lesson is to figure out whether an ionic compound will be soluble or insoluble in water. If the ionic compound in the products is soluble, then the double replacement reaction is not spontaneous. But if the ionic compound is insoluble, then the double replacement reaction will be spontaneous. So to determine whether ionic compound is soluble or insoluble, we'll be using table F on the reference table. Table F is on the reference table. It is the solubility rules for ionic compounds, whether they dissolve or not in aqueous solutions. So there's two tables on table F, ions that form soluble compounds and ions that form insoluble compounds. So be careful when reading table F. Table F is only for double replacement reactions. If your ionic compound is soluble, it means it will dissolve in water at STP. If the ionic compound is insoluble, it means it will precipitate at STP. It will form an insoluble solid in the aqueous conditions. If there's an exception, it is the opposite. In the two tables, there's an exception column. It means when the ions on this list bond with these ions in the exceptions, it will be the opposite of what's written here on top. For example, if you have Ag plus bonding with Cl minus, this is an exception. Therefore, AgCl will be insoluble. So for the SCD2 and AP, you have to memorize the solubility rules of table F. In a double replacement reaction, you're forming two ionic compounds. If one of the ionic compounds is a precipitate, then the entire reaction is spontaneous. Why is that? Because you're forming a new substance, the precipitate, therefore it is a chemical change. If all the products are aqueous, that means both compounds will dissolve in water, then the reaction is not spontaneous. Why is that? because the reactants are mixing together and dissolving in water, and that's a physical change, not a chemical one. Let's do a couple examples on how to read table F. Here we have NaCl, so you notice it has a sodium ion, so we look at this table over here for group 1 ions. Notice there's no exceptions, so every compound with sodium ions is soluble. Let's look at another example. Here we have calcium carbonate. By looking at table F, we're going to look at the second table because it has carbonate ions. So carbonate ions will be forming insoluble compound except under these situations. So the question is calcium a group 1 element? The answer is no. It's a group 2 element. Therefore, there's no exceptions for calcium carbonate. Therefore, calcium carbonate is insoluble in water at STP. Let's look at another example. Here we have silver chloride. Since silver chloride has a chloride ion, we're going to look at this table over here. So these ions will form soluble compound except when it's bonded to these ions here. Since Ag is an exception over here, silver chloride will be insoluble in water at STP. So let's do a learning check. Based on reference table F, which of the following compounds is least soluble in water? On the regions, if you see least soluble, it basically means not soluble at STP. So try to do this yourself, pause the video, and resume once you complete it. So here's the answer. Lead chromate is insoluble according to table F. According to reference table F, which substance is most soluble? On the regions, if you see the term most soluble, it means it's soluble at STP, and the rest are usually insoluble. So take a moment to do this, pause the video, and resume once you complete it. So based on table F, the answer is choice 4, ammonium carbonate. For the rest of the practice, I want you to determine if the following ionic compounds will be soluble or insoluble according to table F. Pause the video and resume once you want to see the answers. So here are the answers. For the next part, I want you to use table F to determine whether the double replacement reaction will be spontaneous or not. So in a double replacement reaction, you're going to look at the products and determine whether each product will be soluble or insoluble based off table F. As long as one of the products is insoluble, then the entire reaction will be spontaneous. But if both products are soluble, then the double replacement reaction is not spontaneous. Let's look at AgCl. From the previous slides, we determined AgCl was insoluble, because when chloride bonds with Ag is an exception according to table F, therefore it is insoluble. For sodium nitrate, sodium, if you look at table F, it is always soluble. Therefore, sodium nitrate is soluble. Since one of the products is insoluble, this double replacement reaction is spontaneous and will happen. In the chemical reaction, we're going to write in the phases. So silver chloride is a solid, and sodium nitrate is aqueous. So now I want you to try the rest yourself. Pause the video and resume once you complete it. So here's the answers. In question 2, we see that water is one of the products, therefore this double replacement reaction is spontaneous. Sodium carbonate, if you look on table F, it is soluble. But because there's water forming, the entire double replacement reaction is spontaneous. For number 3, sodium carbonate is soluble. Potassium nitrate is also soluble. Since both products are soluble, the double replacement reaction is not spontaneous. For question 4, sodium nitrate is soluble. Cesium bromide is also soluble. Since both products are soluble, the double replacement reaction is not spontaneous. For question 5, copper chloride is soluble, but barium sulfate is insoluble. Since one of the products is insoluble, the double replacement reaction is spontaneous. For number 6, calcium sulfate is insoluble, and the other product is soluble. Because calcium sulfate is insoluble, the chemical reaction is spontaneous. In number 7, sodium chloride is soluble, magnesium hydroxide is insoluble. Therefore, this double replacement reaction is spontaneous. In the last question, potassium nitrate is soluble, and ammonium iodide is also soluble. Therefore, this double replacement reaction is not spontaneous. Learning check number 3. Which of the following reactions is spontaneous? Pause the video and resume once completed. So you have to look at the products and determine which one is forming a precipitate. So the answer is choice 2 because barium phosphate is an insoluble solid according to table F. In the last part of the lesson, we'll be talking about ionic equations. Keep in mind that this topic is not on the Regents, but you will see this on the essay too. So first, let's draw a particle diagram of this chemical reaction. So before this reaction, we have silver nitrate and sodium chloride dissolved in water. Then during the reaction, silver chloride was formed and is a solid. That's why this reaction is spontaneous, but notice that the sodium and the nitrate ions are still dissolved in solution. They did not participate in the chemical reaction. This is called spectator ions. They are ions that do not participate in the reaction. They are basically watching or spectating the actual reaction, which is silver ions reacting with chloride ions to form a new substance, silver chloride. In the chemical equation, we are going to write the complete ionic equation, CIE. What is that? It is a chemical equation that shows each and all of the aqueous compounds as separate ions, except for the insoluble solids and H2O, which cannot be separated into ions. For this chemical equation, we're going to write the complete ionic equation, starting with the reactants. Silver nitrate's aqueous, so we can break this down into ions, to silver ion and nitrate ions. Sodium chloride, which is also aqueous, can be broken down into ions. That would be sodium ion plus chloride ions. For the products, silver chloride is a solid which is insoluble, therefore we do not break it apart. For sodium nitrate, since it's aqueous, we can break it apart into separate ions. That becomes sodium ions and nitrate ions. So this is the complete ionic equation. Notice there are some identical ions on both sides. We can cross them out like we do in math, and then we can get a net ionic equation, which only include ions that participates in the reactions. We're basically crossing out the spectator ions. So notice that the nitrate ions is present on both sides. We can cross them out. The sodium ions are present on both sides as well. We can cross them out. So notice we're crossing out the spectator ions. They are not participating in the reaction. They are still dissolved in the solution. So what we have left is the net ionic equation, which is silver ion plus chloride ion gives us silver chloride. So notice there's no spectator ion in the net ionic equation. Now I want you to try this practice on your own. Write the complete and net ionic equation of the following double replacement reaction and identify the spectator ion. Pause the video and resume once you complete it. Here are the answers. So this concludes the video lesson for today. Remember to do the Junipod homework.